Welcome to Super Series session. In this session, we are going to discuss some questions from signals and systems. Here, the signal is a sum of cosine and sine function. We want to find the period. So, in general form, we know that the signal is represented by cos omega t or by sine omega t. So, from here, we can write omega 1 that is equal to pi by 4. From this term, we can write omega 2 that is equal to pi by 3. So, we know that omega 1 that is equal to 2 pi by t1. This implies t1 that is equal to 2 pi by omega 1. Now, substitute for the value of omega 1. We get t1 is equal to 2 pi divided by pi by 4. This implies T1 is equal to 8. Similarly, T2 that is equal to 2 pi divided by pi by 3. So, T2 is equal to 6. Since this is a sum of these two terms, so the common period is the LCM of T1 and T2. That means common period T is equal to LCM of T1 and T2, that is equal to LCM of 8 and 6, that is equal to 24. So, the period of this signal is 24. Again, we want to check one more condition, that is T1 by T2. This ratio should be a rational number. Here T1 is 8 and T2 is 6. So, this is equal to 4 by 3. So, the ratio of T1 and T2 is a rational number. Now, consider the second question. Here, T1 that is equal to 2 pi by root 2 and T2 that is equal to 2 pi by 2. 1 is equal to root 2 pi and T2 is equal to pi. Now, the ratio T1 by T2 that is equal to root 2. This is not a rational number. So, this is not periodic. So, our option is the period of first signal that is 24 and second signal that is non-periodic. So, C is the correct option. In this question also, we want to find the period of a discrete time signal. The signal is sum of two terms cos pi n by 4 plus cos pi n by 3 and options are given. So, in general form, we can write this as cos omega 0 n. Here, omega naught that is equal to pi by 4 and here omega naught that is equal to pi by 3. So, we can write omega 0 that is equal to 2 pi by n. For first portion, this is represented by n1. So, period n1 that is equal to 2 pi by omega naught. That is equal to 2 pi divided by pi by 4. So, this is equal to 8. Here, we can find period n2 that is equal to 2 pi divided by pi by 3. This is equal to 6. So, the common period n that is the LCM of this 8 and 6 that is equal to 24. So, this signal is periodic with a period n is equal to 24. So, B is the correct option. Here, we want to find impulse response of the system and options are given. So, our input is an impulse input. So, we can represent x of n that is equal to del of n. Now, substitute for input in this difference equation. We get y of n. That is an impulse response that can be denoted by h of n. That is equal to x of n is replaced by del of n plus 2 times the input delayed by 1 sample. So, 2 times del of n minus 1 minus 4. Here input is delayed by 2 samples. So, minus 4 del of n minus 2. So, our answer is given in option D.